Hello GW soldiers, how are you? So very good evening to all of you. I am Ajay Gupta and I welcome all of you in my lectures, and in today's lecture we will revise the complete control system through the question. In today's class we are going to do 10 different type of question of control system. So what you have to do? You have to sit with pen, pencil, calculator and of course with your mind and try to solve these questions by your own, because if you are able to solve these questions by your own, it will definitely boost your confidence. No doubt we will discuss the solution of each and every question. So let us start over the session. So this is the first question of today class. This question is a MCQ type. The question say, what is the error between actual magnitude and asymptotic approximation at the corner frequency of open loop transfer function 1 upon s square plus 6s plus 16? That means the open loop transfer function of a system is given, which is 1 upon s square plus 6s plus 16. If you draw the board plot, we can draw the two type of board plot. One is the actual Bode plot and second is called the approximate asymptotic Bode plot. So find out the error at the corner frequency between the actual plot and the approximate plot. So you have to find out error. Good evening, Anjali. So you have to find out the error at the corner frequency between actual Bode plot and the approximate asymptotic Bode plot. So how to find out? This open loop transfer function is having two complex conjugate pole. How to find out the error? What is the approximate asymptotic Bode plot of a open loop transfer function which is having complex conjugate pole? It will be a two straight line, one of 0 decibel line, then at the corner frequency the slope will change from -0 to -40 decibel per decade. And what is the corner frequency for the complex conjugate pole? For the complex conjugate pole, the corner frequency is nothing but the omega n, that is called the natural frequency of the transfer function. Clear? So see, the transfer function is 1 upon s square plus 6s plus 16. 1 upon s square plus 6s plus 16. This is my approximate asymptotic Bode plot. If I draw the actual Bode plot, it may be like this. It may be upside of this or it may be the downside of this. So the difference between approximate plot and the actual plot, it is called the error. It is called the error. So see, if I convert, see, I am taking a very general example of a transfer function. If I am having a transfer function like this, 1 upon s square plus 2 zeta omega n s plus omega n square. This transfer function is having two complex conjugate pole like this. Okay. If I convert this transfer function into time constant form, then it will be like this: 1 minus u square plus j 2 zeta u. I have converted the transfer function from pole 0 form to the time constant form, where u is nothing but omega upon omega n. It is called the normalized frequency. U is called the normalized frequency. So once you are able to convert transfer function into the time constant form, the corner frequency is nothing but the omega n frequency. So what is basically error? So error is nothing but the actual magnitude minus approximate magnitude. What is the error? Actual value minus approximate value. So actual magnitude, actual value means actual magnitude of transfer function at the corner frequency minus approximate magnitude. Magnitude as per the approximate asymptotic body plot. Now, what is the approximate magnitude at the corner frequency? This is the 0 decibel line. This is 0 decibel line. So, at corner frequency, the magnitude is nothing but the 0 decibel. Clear? So, this is the 0 decibel. This is 0 decibel. So, error will be equivalent to the actual value or the magnitude at the corner frequency. So, how to find out the actual value? This is the actual transfer function into the time constant form. If I find out the magnitude of this transfer function, it will be k upon, see, it will be k will be some constant only. So, forget about this k because it will come under the general constant k. So, under root of real part square plus imaginary part square. Clear? This is the magnitude, but we will find out this magnitude in term of decibel. So, how to find out the magnitude in term of decibel? It will be 20 log. If I convert this magnitude into decibel unit, it will be 20 log 1 upon under root means 1 minus u square whole square plus 4 zeta square u square under root means is raised to the power 1 by 2. Clear? So, this is the magnitude at any frequency u, and u is nothing but omega upon omega n. This is the actual magnitude of body plot at any omega frequency. Now, we have to find out magnitude at corner frequency. So, at the corner frequency, omega will be omega n. So, let us solve this one. 20 log x upon y means log x minus log y. So, it will be log x minus log y, log 1 minus u square whole square plus 4 zeta square u square 1 by 2. Log 1 is equivalent to 0. Log x raised to the power n is n log x. So, it will be minus 1 upon 2 log 1 minus u square whole square plus 4 zeta square u square. So, it is become minus 10 log 1 minus u square whole square plus 4 zeta square u square. Clear? At the corner frequency, omega is equivalent to omega n, because at the corner frequency, the frequency is equivalent to omega n only. So, at the corner frequency, omega is equivalent to omega n. If omega is equivalent to omega n, that means the u will be 1 only, because if I put omega is equivalent to omega n here, u is become 1. So, put the value u equivalent to 1, you will get the magnitude at the corner frequency. So, it will become, so this error will be minus 10 log. If I put u is equivalent to 1, it is become 1 minus 1, 1 minus 1 square plus 4 zeta square, u square is 1, so it is 1 only. Clear? 1 minus 1 is 0. So, it is basically 10 log 2 zeta square. log x raised to the power n is nothing but the n log x. So it is become minus 20 log 2 zeta. Clear? So this is the error, or you can say it is nothing but the 20 log 1 upon 2 zeta. This is the error. Clear? It is a very different type of question. So what you have to find out? You have to find out the value of zeta only. So how to find out the value of zeta? Just compare this equation with this equation and you will get the value of zeta. How to get the value of zeta? See, omega n square is equivalent to 16. So omega n square is equivalent to 16. That means the value of omega n will be 4 only. And 2 zeta omega n is equivalent to 6s. 2 zeta omega n s, it is nothing but the s. Clear? So 2 zeta omega n is nothing but 6. 2 zeta omega n is 4. So zeta will be 6 upon 8. That means 3 by 4. So put the value of zeta, which is 3 by 4. So if I put the value of zeta here, so it is become 20 log 1 upon 2 into zeta, 3 by 4. So it is become 20 log 4 by 6. So 20 log 4 by 6 is the correct answer. 20 log 4 by 6 is the correct answer. C is the correct answer. Clear? Now you got how to solve this type of question. It is totally different type of question because generally we find out the error for a simple pole and the simple zero, but how to find out the error for complex conjugate poles and the complex conjugate zero. So in this way you can find out the error for a complex conjugate pole. Okay, so now move to the second question. The open loop transfer function of a unity feedback system is given 8 upon s plus 4 if 20 ut, that means step input of 20 magnitude, is applied in this system. You have to find out the peak value of output. Okay. Find out the peak value of time response. Find out peak value of output of the time response. What will be the maximum value of output that you have to find out? Here I am applying a step input of 20 magnitude. You have to find out the maximum value of output, because if you apply, it is a second order system. If you apply a step input, the step response of a second order system is having several overshoot and the undershoot. So peak value is corresponding with the first overshoot, because the maximum overshoot is the same as the first overshoot. You know what is the response of a step? What is the step response of a second order system? It is like this. It has the several overshoot and the undershoot, and after overshoot and undershoot, it will settle down because it is a underdamped system. So what is the final steady state value? This is my steady state value, and this is the peak output that you have to find out. This is the peak output. We do not have to find out the peak overshoot. We have to find out the output, maximum value of output. Peak overshoot is nothing but the maximum output and the steady state output. So I'm not going to find out the peak overshoot. It is the maximum value of the output that you have to find out. So what is the output at the infinite time? What is the steady state output? It is a unity feedback system. So what will be the closed loop transfer function? Just apply the shortcut trick. It will be numerator divided by numerator plus a denominator. Clear? See, here omega n square is 8. That means omega n will be 2 root 2. If I compare this equation with s square plus 2 zeta omega n s plus omega n square, and 2 zeta omega n is the 4. 2 zeta omega n is equivalent to 4. So what will be the value of zeta? 4 upon 2 omega n. 4 upon 2 into 2 into root 2. That means zeta is 1 by root 2. 1 by root 2 means it is less than 1. So it is a underdamped system. It is nothing but the underdamped system. That's why I have drawn the response of a underdamped system only. It is an underdamped system. Now what will be the final output? How to find out the final output? We can find out the final output by applying the final value theorem. See, so what is the final output? If I find out the output when time tends to infinite, it is the steady state output. You can find out the final output by using final value theorem. It will be s tend to 0, s multiplied by cs. So what will be the cs? See, here I am, if I represent this system by drawing a block diagram, we are applying 20 ut. 20 ut means 20 by s. This is my input. Transfer function is 8 upon s square plus 4s plus 8. Clear? This is my overall transfer function. So it will be 20 into s multiplied by 8 s square plus 4s plus 8. If I put this value here, it will be limit s tend to 0, s multiplied by 20 by s, 8 upon s square plus 4s plus 8. S and s will be cancelled out. If you put s is equivalent to 0, you will get the 20. So steady state output is equivalent to 20 only. This is my 20. See, if this is the steady state output, this is my steady state output, which is equivalent to 20. Clear? So we know this is called the peak overshoot. Peak overshoot is the difference between maximum output and the steady state output. It is called the peak overshoot. So how to find out the peak overshoot? So let's find out the peak overshoot. So peak overshoot is nothing but exponential minus pi zeta under root of 1 minus zeta square. Clear? Now we have already calculated the value of zeta and it is 1 by root 2. So put the value of zeta here, under root of 1 minus 1 by 2, and find out the value of peak overshoot. Find out what is the peak overshoot. I think it will come 0.0432. Please verify you are getting the same answer for peak. It is not the answer, it is only the peak overshoot, 0.0432. Clear? Now tell me, what is the definition of peak overshoot? The definition of peak overshoot is the maximum output. TP means at this T equivalent to TP. This is called the peak time, the output during peak time, minus steady state output. We always find out the peak overshoot in term of PU or percentage. So it is the peak overshoot in term of PU value. Clear? The output at the peak time, steady state output, and the steady state output. Now we have already calculated MP. It is 0.0432, 0.0432, and we have to find out output at the peak time. This we have to find out output at the time of peak time. Steady state output is the 20. It is 20. Now find out the value of output. It will be 20.86. So 20.86 is the right answer. This is the value of maximum output. Maximum output you will get at the time of peak time. Clear? So do not confuse the maximum output and the peak overshoot, because the peak overshoot is the difference between these two, and this is the maximum output. Clear? Okay. Now come to the third question. It is from the Bode plot. Bode magnitude asymptotic plot is sketched. Find the value of omega 1 at which the two asymptote intersect. We have a two asymptote, one asymptotes and the second asymptotes. At this frequency, these two asymptotes are intersect. What is the value of this frequency omega 1? Find out the value of omega 1. Yes, find out. How to find out? The slope of this line is minus 60 decibel per decade, and for this line is the minus 20 decibel per decade. Are you able to find out the value of omega 1? Now I also teach control system. Basically, I teach all three core subject of electrical machine, power system, power electronics, and two common subject, control system and network theory. I taught 1,000 batches of the control system in offline classes. Yes, anyone? It's a very simple question. Control system is a very easy subject, na? Subject is easy, but question is tough. So how to find out the value of omega 1? See, if you divide a transfer function into several factor, for this factor k upon s dash to the power n, What is the Bode plot? The Bode plot is nothing but the straight line of slope -20 in decibel per decade. Clear? You know, the Bode plot of this factor is a straight line of -20 in decibel per decade, and this straight line cut the x-axis at the frequency of omega is k raised to the power 1 upon n frequency. Clear? So see, the slope of this line, first line, is the -60 decibel per decade. This yellow line, it is a -60 decibel per decade. So -60 decibel per decade. So minus, if I compare this slope with the -20 n, -60, that means the n is equivalent to 3. So this will be a Bode plot of the factor k upon s raised to the power 3. Clear? So this will be a Bode plot of a factor k upon s raised to the power 3. Now, if you know this factor, see, at any omega frequency, if I put s is equivalent to j omega, it will be j omega is raised to the power 3 only. I can find out the magnitude because this is the equation of this line. So I find out the magnitude at any omega frequency. At any omega frequency, you can find out the value of magnitude. But this magnitude are in the decibel. So convert this into decibel. How to convert into this decibel? This will be 20 log magnitude be k upon omega is cube. I am taking only magnitude. So it will be, this is the magnitude. Magnitude at any omega frequency. Now see, at omega 1 frequency, this is the magnitude. So magnitude of this line at omega 1 frequency, at omega 1 frequency, it will be 20 log k upon omega 1 is raised to the power 3. Clear? At omega 1 frequency, this is my magnitude. Once you find out magnitude at omega 1 frequency for this line, now take the second line. This is the second line. Its slope is -20 decibel per decade. See, if I draw this line and again I find out the same magnitude by using this line. So it is a straight line of slope -20 decibel per decade. What is this frequency? I already find out the frequency. Omega k raised to the power 1 upon n is the frequency. So first find out the value of, it is given, na? It is given 100. So this is 100. 100. Now see, this is my omega 1 frequency. I am taking this second line, 100 omega 1 frequency. Now again find out the magnitude at omega equivalent to omega 1. How to find out this magnitude? How to find out this magnitude? This is y coordinate. Y coordinate is nothing but the slope multiplied by x. So the magnitude y coordinate is the m, slope into x. Slope is -20, -20 plus 20. If I am taking this difference of this log 100 minus log omega 1. Clear? Because this scale is a decibel state. So it is become 20 log x minus log y is the 100 upon omega 1. Clear up to this point? Now these two magnitude are the same. First I find out this magnitude by using yellow line, then second time I find out this magnitude by using green line, and these two magnitude are same. So this magnitude and this magnitude are equal. That means 20 log k upon omega 1 cube is equivalent to 20 log 100 upon omega 1. 20 log is the same. That means k upon omega 1 cube is 100 upon omega 1. It is become k upon omega 1 square 100. So omega 1 square will be k upon 100. Clear? So first let us find out the value of k. How to find out the value of k? See, this frequency is k raised to the power 1 upon n. Clear? This frequency is k raised to the power 1 upon n. And in the Bode plot, this frequency is already given. It is nothing but the 100. It is 100. So k will be, and n is 1 by 3. Already find out 100. So k will be well, it is 100 or something. Sorry, it is not 100. I am taking this one. This is 5 for yellow line. Yellow line, it is a 5. No? So it is 5. That means 5 raised to the power 3. It is become 125. Clear? So put the value here. 1.25 divided by 100. 125 divided by 100. It will be 1.25. Now the omega 1 will be under root of 1.25. Find out what will be the answer. 1.118. 1.11, yes, exactly. 1.11 is the correct answer. Clear? So see, what I have done, I find out this magnitude using yellow line equation and using green line equation. I equalize these two magnitude and find out the value of k. I know that for the factor of k upon Sn, the Bode plot is a straight line of slope minus 20 in decibel per decade, and this straight line cut the x-axis at omega equivalent to k raised to the power 1 upon n. So by using this, just find out the value of k and put the value of k here, you will get the value of omega 1. Okay, so now move to the next question. The steady state error in velocity of a system is defined as dr upon dt, dc upon dt when time tends to infinite. This is my steady state error, where r is the input and c is the output. That means the derivative of input minus derivative of output. Generally, we take steady state error as a input, reference input minus output. But here I am taking as a derivative of input minus derivative of output. Clear? Find out the steady state error in velocity, because this is the velocity error, for a input of t cube ut of a unity feedback system. The forward path transfer function of system is given here. So it is not a normal steady state error, it is a steady state error for a velocity, derivative of input minus derivative of output when time t tends to infinite. That you have to find out. It's a different type of question, but the approach will be same. Do not apply any direct formula of steady state error here. See, it is given that error signal E of t is nothing but the value of not RT minus CT. It is the R dot T minus C dot T. So it is not simple R or T. Generally we take RT minus CT. This is the normal steady state error, but here I am taking R dot T and C dot T when time t tends to infinite. Clear? So this is the error in the time domain. We can also find out this error in the S domain or the frequency domain. So what I have to do? We will apply the final value theorem. So apply the final value theorem. If we apply the final value theorem, the time t tends to infinite is converted into S tends to 0. S into, we take it as a Rs minus Cs. Rs minus Cs means the Laplace of, here we use the Laplace of R dot t. Generally, we use here RT minus CT. So Laplace of RT is become Rs and Laplace of CT is become Cs. So Rs minus Cs. But here is the Laplace of R dot t minus Laplace of C dot t. Is it clear to you? S into Laplace of this term, individual Laplace. So it is limit S tend to 0, Laplace of R dot t derivative, it is become S into Rs. Clear? Derivative, the Laplace of derivative, and this will become S into Cs. Clear? So now you can take S term as a common term. So it is become SS, it is become S square Rs minus Cs. So in the normal steady state error, the formula was limit S tend to 0, S into Rs minus Cs. But now it is become S square Rs minus Cs. Rs minus Cs. Now what is the Rs minus Cs? You know? So it is limit S tend to 0, S square Rs minus Cs. And we know whenever we find out the steady state error, we are aware that the difference of input, reference input and the output is nothing but the Rs upon 1 plus Gs. Clear? So put the value here, limit S tend to 0, S square, it is Rs upon 1 plus Gs. Now limit S tend to 0, S square. What is the Laplace of input signal? T square, that means 3 upon S4. Sorry, factorial 3 upon S4. One plus Gs. Gs is 100 S plus 1 S plus 2. S square S plus 3 S plus 20. S square S plus 3 S plus 10. Now solve this. Whenever you solve, you will get 9 upon 10. Confirm whether you are getting the same answer. So in this type of question, do not apply the direct formula. But you know what is the error? Just use the final value theorem to find out the steady state error. But no doubt, you know RS minus CS is nothing but the RS upon 1 plus GS, because the CS will be 1 upon 1 plus GS into RS. So it will be, just put the value, you will get the value of 9 upon 10. Clear? Are you getting the same answer? Okay. So now I move to the next question. This question is little bit easy. The pole zero diagram of a open loop transfer function. Open loop transfer function is given. What is the highest corner frequency of the Bode plot? -1, -5, -4 plus 4j, -4 minus 4j. This is the pole zero diagram of a open loop transfer function. Whenever we draw the Bode plot and the Nyquist plot is always the open loop frequency response. We always use the open loop transfer function. So what is the highest corner frequency of the Bode plot? Yes. Whenever you will draw the Bode plot, what will be the magnitude of highest corner frequency? Corner frequency is the frequency at which Bode plot changes its slope. Yes, this is a simple one. Corner frequency is the frequency at which the Bode plot changes its slope. Convert the open loop transfer function into the number of factor and find out the corner frequency related with each of the factor. So first let me find out the open loop transfer function, because this is the pole zero diagram of a open loop transfer function only. So open loop transfer function, that means the GSHS, see, it has 1 0 at -1. So it is become S plus 1, 1 0 at the -1. Divide by 1 pole at the -5. So it is become S plus 5. 1 pole at -4 plus 4j. So it is become S plus 4 minus 4j. -4 minus 4j. So S plus 4 plus 4j. Clear? So you can easily find out the open loop transfer function. So it has become K S plus 1 S plus 5, see, A minus B, A plus B. That means A square minus B square. To take it as A and B, A minus B, A plus B, A square minus B square. So K S plus 1, S plus 4, S square plus 8S plus 16 plus 16, 32. Clear? So how to find out the corner frequency? We have a different factor in this open loop transfer function. One is this factor, second is this factor, and third is this factor. What is the corner frequency related with this factor? Tell me. For simple poles and the zero, corner frequency is a frequency at which the simple poles and the zero exist. That means you can convert s plus 1 into s plus 1 is nothing but the 1 plus s by 1. So 1 is the corner frequency. So for this factor, the corner frequency is equivalent to 1. Now tell me, what is the corner frequency for this factor 1 upon s plus 4? 1 upon s plus 4. What is the corner frequency? It is become s upon 4 plus 1. The corner frequency is the 4. For simple pole and zero, corner frequency is the frequency at which the simple pole or simple zero exists. Oh, sorry, 5. This is the 5. So it will be 5 only. So corner frequency will be 5 here. Now what is the corner frequency for the complex conjugate poles and the complex conjugate zero? For complex conjugate poles and complex conjugate zero, the corner frequency is nothing but the omega n. So find out the omega n for this factor, s square plus 8s plus 32. To find out the omega n, I am comparing this term with a general term, s square plus 2 zeta omega n s plus omega n square. Clear? Now omega n, that we have to find out. So omega n is square is the 32 and omega n will be 400 root 2. This is the third corner frequency. Now out of 3 corner frequency, 1, 5 and 4 under root 2, which is the highest corner frequency? Tell me. The 4 under root 2 is the higher than 5. So 4 root 2 is the highest corner frequency. D is the correct option. Clear? So for simple pole and zero, the corner frequency is a very simple. It is the frequency at which simple poles and the zero exist. But for complex conjugate poles and complex conjugate zero, corner frequency is the omega n. Okay. Very simple question from Routh-Hurwitz criteria. The open loop transfer function of the system is given k s minus a divided by s minus b. What is the range of k for which closed loop stability when a is less than 0 and b is less than 0? It is given a is less than 0 means a is negative and b is less than 0 means b is also negative. So for which value of k the system will be stable system? Apply the RH criteria, Routh-Hurwitz criteria. The open loop transfer function is given. First find out the closed loop transfer function and apply the Routh-Hurwitz criteria in characteristic equation of the system. This is a simple one. C, k is greater than b. Oh, one thing is missing. Basically, open loop transfer function of a unity feedback system. It should be the unity feedback system only. Because for unity feedback system, we can find out the only for unity feedback system, we are able to find out the closed loop transfer function. Clear? So I am just finding out the characteristic equation. That will be the 1 plus a g of s, h of s will be 1 only. So it is 1 plus k s minus a s minus b. It will be s square minus bs plus ks minus ak. S square plus sk minus b minus ak is equivalent to 0. Clear? This is the characteristic equation. For second order system, this is the necessary and sufficient condition. If the coefficient of these equation is positive, the system will be stable system. But suppose if you are not able to understand this thing, you can also apply the Rao-Hurwitz criteria here. So if I apply the Rao-Hurwitz criteria, the highest order of this equation is s square. It is s square. Now take the alternate coefficient 1 minus ak. It is 1 minus ak. Now s, this coefficient is k minus b. It will be k minus b 0. Clear? Again s not 0, it will be multiplied with this, you will get the minus ak only. So for a system to be stable, 1 is a positive number. So there should not be any sign change. That means this number should also be positive and this number should also be positive. Simple. For a system to be stable, that means minus ak should be positive. Positive means its value should be greater than 0. Any number whose value is greater than 0 is a positive number, or any number whose value is less than 0 is a negative number. But a is a negative number because a is less than 0. That means a is a negative number. It may be minus 1, minus 2, minus 10, minus 20, anything. So if a is negative number, that means minus a will be positive number. If a is negative number, that means this number is a positive number. This number is a positive number. This is a positive number, minus a. So the k is greater than 0. Positive number multiplied by k, that means the k is greater than 0 only. If it would be a negative number, then it would become k is less than 0. So this is my first equation. Now come to the second equation, k minus b. K minus b, it should also be a positive number. That means its value should also be greater than 0. That means the value of k should be greater than b. What it mean? B is my negative number only. B is again less than 0. That means b is negative number only. Suppose b is minus 3. This time imagine that b is minus 3. It is saying the k should be greater than b. What it means? K should be greater than minus 3. It may be minus 2, minus 1, 0, 1, 2, 3 or anything. Clear? But according to this, the k should also be, so k must be only positive number. So if I take 1 and 2 simultaneously, you will get the k should be greater than 0. Because we have to take the condition which should satisfy equation number 1 as well as equation number 2. Clear? So here k may be some negative number, 0 number or positive number, but as per this condition, the k should be only positive number. That means the k should be greater than 0. So A will be the right answer. Clear? Rao-Hurwitz criteria. Okay, now come to the next question. The open loop transfer function of a system is given GAS, G of S, H of S, K upon S, S plus 1, S plus 2. You have to find out the value of K for which gain margin is equivalent to 3 decibel. The gain margin is given in decibel. Clear? So you have to find out for which value of K the gain margin would be 3 decibel. Yes, find out the value of K. The open loop transfer function is a type 1 and order 3. So what will be the polar plot? Type 1 and order 3. This will be a polar plot. This is A. A is nothing but the magnitude of open loop transfer function at omega is equivalent to omega p frequency. See, so how to find out the gain margin? The 3 step is required. The first step is find out omega p. Omega p is a frequency at which the phase angle of open loop transfer function is become minus 180 or plus 180. Now the second step is that at this omega p frequency, find out the magnitude of open loop transfer function. Find out magnitude of open loop transfer function GS HS at omega equivalent to omega p frequency. And what is the third step? Third step is the inverse of A is the gain margin. But if you have to find out the gain margin in decibel, it will be 20 log 1 upon A, or you can say it is a minus 20 log A. Clear? So this is given. Gain margin is the 3 decibel. So third one is given, it is 3 decibel. Three decibel is the gain margin. 20 log 1 upon A. 20 log 1 upon A. That means log. It is a log at the base of 10. Is the 3 upon 20. So what is the 1 upon A? 1 upon A will be the 10 raised to the power 3 by 20. What will be its value? 3 by 20, 0.15, 1.41. So A is become 1 upon 1.41, 0.707. Clear? So 0.707 is this magnitude. And how to find out this magnitude? First, we have to find out the omega p, and that omega p, find out the value of A. So how to find out the omega p? See, now I'm going to find out the omega p. The open loop transfer function is K S S plus 1 S plus 2. If I convert this transfer function into sinusoidal form by putting S is equivalent to j omega, so it is become 1 plus j omega, 2 plus j omega. Now what is the phase angle at any omega frequency? The phase angle of numerator is 0. Phase angle of j omega is minus 90, minus tan inverse omega, minus tan inverse omega by 2. This is the phase angle of open loop transfer function at any omega frequency. So when omega is become omega p, this phase angle is become minus 180 degree. So this phase angle is become minus 180 degree when omega is become omega p. So it is tan inverse omega p plus tan inverse omega p by 2. If I bring this term here, it has become positive, it is 90 degree. So tan inverse omega p plus omega p by 2, 1 minus omega p square by 2, 90 degree. That means 3 omega p by 2, 1 minus omega p square by 2 is the tan 90, and tan 90 is nothing but infinite. Infinite means this term should be 0. So the omega p is nothing but the under root 2. Clear? This is the under root 2. If you know the omega p, now what is the value of A at omega p frequency? The magnitude of this A at the omega p frequency. So magnitude GSHS at any omega frequency will be, magnitude of K will be the K only. Magnitude of j omega is the omega. Magnitude of 1 plus j omega is the 1 plus omega square, and it will be 4 plus omega square. So at omega equivalent to omega p, it is equivalent to A. Now we have already calculated A, it is 0.707, 0.707 K. Omega p was under root 2, 24, 2 plus 3, 3, 6. So K will be 0.707 into 6. 4.24 is the value of K. Clear? So 4.242 is the right answer. Okay. Now move to the next question. The open loop transfer function of the system whose open loop transfer function is -1 upon 2s 1 minus 20s. The Nyquist plot will encircle the point 1 0, not -1 0, it is a 1 0. The point which lie on the right hand side of the S plane. How many times the Nyquist plot is encircling the point 1 0? First you have to draw the Nyquist plot. For drawing the Nyquist plot, first we have to draw the polar plot for the positive range of frequency. Then we have to draw the polar plot for the negative range of frequency. Even if the plot is the open plot, then you have to close this plot. It would become Nyquist plot. So GSHS, the open loop transfer function, the sinusoidal open loop transfer function is, if I put S is equivalent to j omega, 1 minus 20 j omega. This is the sinusoidal transfer function. Clear? Its magnitude will be 1 upon 2 omega 1 plus 400 into omega square. This is the magnitude at any omega frequency. And what is the phase angle? Phase angle of -1. What is the phase angle of -1? Yes, phase angle of -1. It is 0 degree or 180 degree? 180 degree, great. So angle of numerator is the positive, angle of denominator, phase angle of j omega is the 90 degree. And what is the phase angle of this? It will be in the real part is positive, imaginary part is negative, that is in the fourth quadrant. So it is minus tan inverse minus 20 omega upon 1. Tan inverse minus theta is the plus tan theta. So it is become 180. Tan inverse minus theta is become plus tan theta. Tan inverse minus theta minus tan theta, sorry, minus tan inverse theta. It is become 20 omega. Clear? So it is become 90 minus tan inverse 2 omega. So phi is become 90 minus tan inverse 20 omega. So this is the magnitude and this is the phase angle. So first I am finding out the magnitude and phase angle at two critical frequencies, 0 frequency and the infinite frequency. When omega is equivalent to 0, what is the magnitude of open loop transfer function? If you put omega equivalent to 0, it is become infinite. So magnitude is infinite. And what is the phase angle? If I put 0 here, it is become 90 degree. Clear? Second, at the infinite frequency, the magnitude is become, if you put omega equivalent to infinite here, it is become 0. And what is the phase angle? 90 minus tan inverse infinite. 90 minus 90 means 0 degree. And from this it is clear, whenever you are going to increase the omega, the magnitude will continuously decrease. If you increase the omega from one value to another value, the magnitude will continuously decrease with increasing the value of omega. And second is, if you are going to increase the value of omega, the phase angle will change from 90 to 0 degree only. So how to draw the polar plot? First, draw the polar plot. How to draw the polar plot? Infinite at the angle of 90 degree. Infinite at the angle of 90 degree. See, basically you have to draw so many phasor, and then it has become 0 degree. This is a 0 degree. This is my polar plot. Magnitude is continuously decreasing, and the phase angle is changing from 90 to 0 degree. Continuously it is changing from 90 to 0 degree. So it is at omega equivalent to 0 plus frequency. It is omega equivalent to infinite plus frequency. Clear? Now draw the mirror image of this polar plot with respect to real axis. If I draw the mirror image, this will be polar plot for the negative range of frequency. The mirror image of omega 0 plus will be 0 minus. The mirror image of infinite plus will be infinite minus. Here arrow is the 0 to infinite. Here the arrow will be minus infinite to 0, because this is the mirror image. Clear? Now see, this, even if you draw the polar plot and its mirror image, this plot is a open plot. Now you have to close this plot to form the Nyquist plot. So this is a type 1 system. In the type 1 system, the 0 plus and the 0 minus end will be opened. You have to close these end by making n pi clockwise encirclement. N into pi clockwise encirclement. You have to close these end. What is the n? N is 1 only. It is a type 1 system. So you have to make a pi clockwise encirclement. The radius of encirclement will be infinite. Infinite. How to draw the clockwise encirclement? You cannot draw this type. Why? Because arrow does not match here. Arrow is not matching here. The arrow should also be match. So clockwise encirclement, pi. See here. Now tell me how many time it is encircling? The 1 0 1 0 will be here somewhere here. It does not encircle. The D is the correct answer. If they were asked how many times it is encircling minus 1 plus j 0 point, then the answer would be 1 time. But in this question, they are asking 1 0 point, not minus 1 0 point. Clear? So first you have to draw the Nyquist plot and then find out how many times it is encircling 1 0 point. So next question, very simple one. The open loop transfer function of a system is given 1 upon s plus 1. What is the gain margin of the system? What will be the gain margin of the system? This is the question number 8. B 1. See, open loop transfer function 1 upon s plus 1. It is like 1 upon 1 plus st. Type 0 order 1 system. How to draw the polar plot of type 0 order 1 system? You can use the trick to draw the polar plot. The polar plot of 1 upon 1 plus st is like this. Where omega is 0 plus, here omega is the infinite plus. Clear? If I draw the mirror image of this is the mirror image. It is become 0 minus, and the mirror point of this point will be the infinite minus. So this is the Nyquist plot. Now tell me, what is the omega p here? What is the omega p? Can you find out the omega p? What is the omega p? The definition of phase crossover frequency. The definition of phase crossover frequency is that the frequency at which the magnitude of open loop transfer function is become minus 180. Or the second definition like that, the frequency at which polar plot cut the negative real axis like this. The frequency at which the polar plot cut the negative real axis is called the phase crossover frequency. But in this Nyquist plot or the polar plot, it is not cutting the negative real axis. It is not cutting negative, it is not zero basically. It is not cutting the negative real axis. It is cutting at the origin. That means omega p does not exist. For this transfer function, the phase crossover frequency does not exist. If the phase crossover frequency does not exist, then what would be the gain margin? If the phase crossover frequency of a system does not exist, then the gain margin will be infinite only, not zero. It is the infinite. Similarly, if gain crossover frequency does not exist, then the phase margin would be infinite. And if the phase crossover frequency does not exist, the gain margin would be infinite. Clear? Okay, now come to the second last question from the state variable. The state equations and the output equation is given to you. You have to find out the zero state response. If the initial condition is 1, 2 is the transpose. How to find out zero state response? So what is the zero state response? It is nothing but phi t state transition matrix into x naught. So x naught is already given. It is given to you. So what you have to find out? You have to find out the state transition matrix. You have to find out the state transition matrix. And how to find out the state transition matrix? It is nothing but the Laplace of phi s, or we can say the Laplace inverse of Si minus A inverse. Clear? So Si minus A, this is matrix A, this is matrix B, this is matrix C. So Si minus A matrix. So my A, the order of A matrix is the 2 by 2. So always choose the identity matrix of 2 by 2 order. So it is 1, 1, 0, 0. Clear? S into I minus A. What is the A? Minus 2, 1. 2 minus 3. This is S I minus A. So it is become S plus 2 minus 1 minus 2 S plus 3. This is my Si minus A matrix. Now the inverse of Si minus A matrix. How to find out the inverse of 2 by 2 matrix? We can use the direct trick here. First, take the determinant S square plus 5S plus 6 minus 2. Interchange its position. It is become S plus 3, S plus 2. And change the sign of these two. It is become 1 and 2. So it is a direct method to find out the inverse of a 2 by 2 matrix. So S square plus 5S plus 4. That means it is S plus 4, S plus 1. S square plus 5S plus 4. S plus 3, 1, 2, S plus 2. Clear? This is the Si minus A inverse. That means it is a phi S basically. It is a phi S, the Laplace transform of state transition matrix. If I multiply this term with each element in the matrix, then it will become S plus 3 S plus 4, S plus 1, 1 upon S plus 4, S plus 1, 2 upon S plus 4, S plus 1, S plus 2 upon this is my phi S. Now we have to do the inverse Laplace of this matrix. How to find the inverse Laplace? For inverse Laplace, we have to do the partial fraction expansion. So what will be the partial fraction expansion of these term? A upon S plus 4 minus 4, that means minus 1 minus 3, 1 upon 3, 1 upon 3 S plus 4 plus 1 minus 1, minus 1 means 2, 2 by 3. So it is 2 by 3 S plus 1. Clear? Here S plus 4, 4 means minus 1 upon 3. Minus 1 clear. Now minus 2 upon 3 S plus 4 minus 1 2 by 3 S plus 4 S plus 1. Clear? Minus 4 minus 2 minus 3 2 upon 3 S plus 4 minus 1 1 upon 3. Is it right? Clear? So if I take the inverse Laplace phi t, phi t is nothing but the inverse Laplace of phi s. One upon 3 e raised to the power minus 4 minus 4t. 2 by 3 e raised to the power minus t. Minus 1 upon 3 e raised to the power minus 4t plus 1 upon 3 e raised to the power minus t. Minus 2 upon 3 e raised to the power minus 4t. 2 upon 3 e raised to the power minus t. It is again 2 upon 3. Two upon 3 e raised to the power minus 4t. One upon 3 e raised to the power minus t. Clear? Now we have to find out the xt, which will nothing but the phi t multiply by x0. Clear? So multiply it by x0, and x0 is the transpose of 1 2 1 2. So if I multiply this matrix by 1 2, just multiply this by 1 and 2, the transpose is convert row into column. Now what you will get? 1 2 minus 2 upon 3, 1 upon 3, that means minus 1 upon 3. 2 2, 4 upon 3. 2 2, 4, 4, that means 2 upon 3 e raised to the power minus 4t. Again 4 upon 3 e raised to the power minus t. So what is the answer? If you take 1 upon 3 as a common term, if I take 1 upon 3 as a common term, it is become 4 e raised to the power minus t minus e raised to the power minus 4t. 4 e raised to the power minus t plus 2 e raised to the power minus 4t. Plus 2. This A is the correct answer. Clear? So slightly lengthy question. And now finally we have come to the last question of this lecture. It is from compensator. The pole zero diagram of a lead compensator is given. It has one pole and the 1 0. R1 is equivalent to, this is a pole zero diagram of this compensator. If R1 is 10 kilo ohm, then what is the value of R2 and C? You have to find out the value of R2 and C. Last one, On 24th, we will revise the power system and the power electronics in English channel at the same time. So you can join that class too. How to find out? First, find out the transfer function of this lead compensator and see where the pole and zero of this transfer function is lying on the complex plane. And the location of pole and zero is already given. So you can compare the pole and zero with the actual pole and zero. So R and C, see if I convert this into the S domain, it is become 1 upon SC. So the overall, the impedance of this is the R1 into 1 upon SC, R1 plus 1 upon SC, because R1 and 1 upon SC, two impedance are connected in parallel. So it will become R1 upon R1 CS plus 1, clear? And it is R2 only. So now we have reduced this electrical network into this form. This is R2 and the equivalent of this impedance become R1 upon R1 CS plus 1. Clear? Now find out the transfer function. If this is input voltage VIS in S domain and the output voltage is the voltage across R2. So what is the transfer function? Just use the voltage division rule. V naught S upon VIS. Just use the voltage division rule. The impedance of R2 is R2, sum of total impedance. So it is the R1 upon R1 CS plus 1 plus R2. Clear? So finally it will become R2 R1 C1 S plus 1, and this would be R1 plus R1 R2 CS plus R2. So you can write in this form R2 R1 CS plus 1. It is not C1, it is only C. And here R1 R2 CS plus R1 plus R2. Clear up to this point? Now the roots of numerator is the zeros of transfer function and the roots of denominator is the pole of the transfer function. So what is the zero? How to find out the zero? The roots of numerator. What is the roots of numerator? R2 is a constant only. R1 C1 S plus 1. R1 C S plus 1. The roots S will be minus 1 upon R1 into C. This is the location of 0. Clear? And what is the location of 0? It is given in this pole 0 diagram. It is nothing but minus 2. The location of 0 is nothing but the minus 2. So it is equivalent to the minus 2. So we can say the C is nothing but 1 upon R1. The value of C is nothing but the 1 upon R1, and the value of R1 is already given in the question. It is the 10 kilo ohm. So 1 upon 10 kilo ohm. 10 into 10 raised to the power 3. So it will be 50 microcoulomb. Clear? So values of the C will be the 50 microcoulomb. So either B and the C will be the right answer. Now The location of pole will be given by the roots of denominator. So find out the location of pole. It is R1, R2, CS, R1, R2, CS plus R1 plus R2. So pole is lying at minus R1 plus R2, R1, R2 into C. Clear? And what is the exact location of pole? The exact location of pole is the minus 4. So its value should be equivalent to minus 4. Its value should be minus 4 only. Now, see, minus minus will be cancel out. It will be R1 plus R2, R1, R2, C. 4 R1, R2 into C. So R1 is given 10 coulomb. So it is the 10 coulomb. R2 we have to find out. 4 R1 plus R2, 4. R1 is again 10 coulomb. R2 we have to find out. And C. So you can say 1 upon R1C. 1 upon R1C direct 1 upon 2. R1C is the 1 upon 2. So R1C you can directly write 1 upon 2. So 4 R2 into 1 upon 2. So it is become 2 R2. 2 R2 minus R2. R2 is equivalent to 10 coulomb. It is again 10 coulomb. So 10 coulomb and the 50 microfarad. D is the right option. So what you have to do? Just find out the transfer function, because the electrical compensator is already given to you. Then find out the location of poles in 0. The location of poles in 0 is already given into the pole 0 diagram. So compare the location of pole and location of 0 and find out the value of R2 and C. So this is all about today class. Today I have discussed the 10 very different type of question of control system. I hope it would be beneficial for you. So we will meet again at 24th of January, and on 24th of January we will revise the power system and power electronics. Clear? Okay. Till then, goodbye everyone. Thank you.